Price, and today I'm going to be showing you my artifact. I have made a house living room, which is here. Alright, this assessment has been aimed for the stage 3 age group, potentially just year 6. This stage is appropriate for building this artifact as it requires materials that need maturity. Also fits within the syllabus of this age group. This model was selected to create as it draws interest from everyday life, such as in individual students' homes, giving them ability to imagine, create and construct using their experiences through their learning process. Alright, this artifact has met the criteria of having light, movement and sound. By doing so, I've been able to show you, I'll come up a little closer. So I have a moving fan. I also have a buzzer and also my light switches. These all connect on a parallel and series circuit. So my 2 lights are in series and in parallel. All 3 circuits are in parallel. Motor and fan is parallel with the light and the buzzer, and the switch is evident on each circuit. Alright, my demonstration. Alright, I'm going to turn all 3 of my switches on, which are based on the top. So I have my lights, my fan, and my buzzer. Once I turn my buzzer off, my fan and my lights are still working. Once I turn my fan off, my lights are still on. Now, if I turn these anti-clockwise, both lights will turn on. They are in parallel with each other. Once I turn them back clockwise, they will turn back on again. Now, this can work on its own, and each circuit can work on its own. I can show you this as well. So my lights, my fan, and my buzzer. Now, so as I just demonstrated, when all 3 switches are turned on, all 3 components are working. The lights turn on, fan will spin, and the buzzer will ring. All maintain the same energy from one power source, which is my 6-volt battery. All components can work individually, maintaining the same energy. The lights are in series with one another and is also working in parallel. In the demonstration, if one light is turned anti-clockwise, both lights will turn off. If the light is turned back clockwise, both lights will turn back on again. My scientific concepts. For students to understand the key concepts and structure of this artifact, mathematics of inquiring and trial and error based on voltage of the battery, singular power source required to flow to all working circuits equally. This way to communicate this is through visual cues in the classroom. For example, diagrams and a word wall. By supplying all students with physical diagrams, which I have provided here, which is my physical diagram which will be on my PowerPoint, will give students the knowledge and positioning to structure their circuits correctly, both supplying for their parallel and series circuit. With the help of the primary connection source, this is an example of a word wall. By including a word wall in my classroom, I'm able to support science and literacy experiences of reading, viewing, writing and speaking. Provide a visual representation to help students see patterns in words and decode them. Develop a growing bank of words that students can spell and read. Provide ongoing support for the various levels of academic ability in the class, and teach the strategy of using word sources as a real-life strategy. Now, the way I would reflect this in the classroom is I would give the students a scenario that is relevant to them. So the way I would demonstrate this is I would say, students, now we have built our living room. Now, let's break this down. I need lights. Lights need on so I can see in the dark. I need a fan to maintain a very cool environment in the scorching Australian heat. I need a motor to hear when all my friends are coming over. So let's build this together. By including the diagram for each student, they are able to build this with a physical copy and are able to see individually as well. This is my circuit diagram. So as you can see, this is an exact diagram of what I have provided. So my 6-volt battery is my one source to power each circuit equally. I do have my 2 lights here with my switch. In my first circuit, I then do another switch with my motor, and then I have another switch with my buzzer. Now this is going to be one circuit, that is my parallel series, And these are working in parallel with each other, my buzzer and my fan. My links to the science and technology syllabus. This model enables students to learn connection and investigation of creating parallel and series circuits, working simultaneously in conducting loops using wires, switches, 6-volt battery, light bulbs, motor and buzzer. By creating simultaneous loops as visible on the diagram will allow students to visualise the difference of continuous circuit and parallel circuits. It is visible to also connect to sustainability strands as recycled materials were incorporated in the interior and exterior of the model. Therefore, students can link their own experiences and lives within the artefact. Alright, my indicators. My outcomes include to the physical world. So they are plan to use materials, tools and equipment to develop solutions, explain how energy is transformed from one form to another, investigate the effects of increasing and decreasing the strength of specific contact and non-contact force. Lastly, plan to conduct scientific investigations that are testable and are able to collect information from this. Therefore, students are able to accurately cut, join, bend and measure a range of selected materials, demonstrate safety and sustainability when choosing resources, and develop a project plan. Now, this can involve into our English syllabus as well, in working in teams to include that collaborative learning. My general capability. This artefact thrives from a 5E framework. By doing so, this empowers creative thinking. The capability of critical and creative thinking gives students the tools to examine the world they live in, analyse their findings and reach conclusions using evidence. Students are provided with the opportunity to harness a rich knowledge of each subject and apply their critical and creative thinking in ways that are specific to the subject. My cross-curriculum priorities. This is linked directly from the NESA website. Encourages students to develop, acknowledge and take into consideration environmental, social, cultural and economic systems. Therefore, students can develop knowledge regarding management of natural resources, as teachers need to provide for students in the right tools to enhance learning from the classroom to the real world. Displaying sustainable pedagogies aligning with the 3R, reduce, reuse and recycle were used throughout this artefact as well. So, we are linking to sustainability for this assignment, and I've included the resources I've used. So I've used a cardboard box for the construction, build and exterior of the artefact, interior decoration created from same cardboard box, paddle pop stick for the fan, and then reduce, no waste by allowing students to play with the artefact in the classroom as a reward and display as an exit slip activity through a gallery walk. Reuse paddle pop stick and ice cream box, and lastly recycle cardboard is recycled into the exterior and interior of the house. Alright, my link to 2 KLAs. I've linked to geography as factors that shape environments, explains interactions and connections between people, places and environments. By doing so, students are able to make their artefact through their gallery walk. They're able to compare what they have made and their different environments to their classroom. As well as creative arts makes artefact for different audiences, assembling materials in a variety of ways. Students can customise their artefact utilising differentiation items that can have found in their home and utilise these individual characteristics to make their artefact relevant to them. Alright, my trial and error. So we firstly tried this with less voltage. So we tried a 3-volt battery. On the running battery, running 3 conducting loops opposed a challenge. This is as all of the battery voltage was not able to connect equally to all of our circuits. Therefore, we did try to move on to a 6-volt battery, and then all power and energy was forced equally amongst all 3 circuits. Oh, let's go back. All right, in the classroom, the purposeful of prioritising engaging activities with the classroom environment is to enable students to develop inquiry minds about science and their evolving world. However, this opposes challenges such as frustration, the amount of children skipping ahead of direction and sharing the building process. Now, inquiry-based learning is great in this assignment, involving the 5E model framework again to encourage active and planning process to build such artefact, allow students to investigate, research and problem solve to find how to make all 3 conducting loops work simultaneously. This can be done by breaking down the lesson, dividing occasion for construction for each component to be completed solo with group, and after some time with the teacher to demonstrate how and why to connect the elements. Lastly, my costs. So in relation to this assignment, I did use our Kit 1 and Kit 2 provided by the JCAR team. So I have, they were both $9.95 each, and then I did find stuff at home to make the fan, which include the Paddle Pop stick, and the interior is the ice cream box pictures. Therefore, it came to $19.90. And then lastly, I've re-included my resources. So, thank you for watching my assignment. How many minutes?